Hello, and welcome to Mrs. Law's class. In this lesson, we're going to take a look at some applications of linear equations. Now, when writing a linear equation to describe a situation, we need to be able to find the slope and the y-intercept of the problem so that we can write the equation. So let's take a look at an example. So the first one, the cost to rent the theater for a group of students is a fixed rental fee plus a cost per student. If 25 students attend, the cost is $305. If 40 students attend, the cost is $410. All right, I'm going to start by drawing a rough graph so you can see how this situation applies to a graph, and then we'll interpret the graph to write the equation. So let's say that each one of these marks is 5, and I'm only interested in 25, 30, 35, and 40. So I'm just drawing a rough one. Even my scale is not totally correct. Then we have $305. So let's say that this was 100, this was 200, 300, and 400. So at 25, it's 305, so it's a little bit right there. And then at 40 students, it's 410. All right, so if I take my ruler and I'm going to connect my 2 points. Okay. What is the cost per student? That's the first question. So we know that from the graph, there is a change in the cost. So when there are 40 students, it's $410. And when there are 25 students, it's 305. So we're going to find the difference between these numbers. So that would be the distance from here to here. Okay. And then we're also going to divide that by the distance from 40 to 25. Okay, so when we do this, we're going to get 105 divided by 15. Okay, and when we calculate this, we're going to get 7. So this is actually going to be $7 per student. Okay, so that is how we can figure out the cost per student. By taking the difference between the cost and the difference between the amount of students, we can figure out how much it would cost for one student. Now, when we take a look at this value on the graph, notice that the 410 minus 305, that actually represents our rise in the graph. And the 40 minus 25, that's down here, that difference is our run. So the $7 per student, that actually represents our slope of the graph. And the slope of a linear equation. All right, next, part C says, what is the rental fee for the theater? So the rental fee for the theater would mean that even if no students attended, we would still have to pay for a fee. So if you look at the graph, if there were no students, so this is students on the bottom, or number of students, we should say, we can see that there's a point here, which looks like it's maybe 135 or 140. So we can actually calculate this algebraically. So we know that the slope is already $7, and we know that we have the equation of the line, which is y equals mx plus b. So we're going to plug in our 7 for slope. Okay. Now, what we want to do is find out what this purple point is here on the graph. And that purple point is a y-intercept. We do have some points, x and y, from the graph. So these 2 points here. Let me color them a different color. And these points were also given to you in the beginning of the problem. So we have 25 and 305 as one point, and 40 and 410 as another point. So let's write those down. So you have 25, and let me scroll back up. So that was 305. Okay, and we also have 40 and 410. So these points represent x and y because they're all points on this line. This equation also represents the equation of a line. So what I'm going to do is I'm going to plug in the 25 for x and the 305 for y. So I'm going to get 305 equals 7 times 25 plus b. Okay, and then I'm going to multiply my 7 times 25, which is 175, and that's plus b. And then I'm going to subtract 175 from both sides. So I find out that b is 130. All right, if I plug in 40 and 410, a different point, but it's also on my line, this is going to be x and y again. So I have 140 equals 7 times 40 plus b. Oh, no, sorry, not 140. Should be 410. Okay, so I got 410 equals 280 plus b minus 280 on both sides. And I find that b is equal to 130 again. So you can see that it doesn't matter which point I use, as long as those points are on the line, the b value will be the same. So this b value is $130. So the rental fee is $130, and it represents the Y-intercept. All right, so in part D, it says write a let statement to identify the independent and the dependent variables. So the independent variable is, in this case, is our number of students. So I'm going to say let n equal number of students. And if you keep reading the question, actually, which we should have done, it says write a linear equation that relates the cost of renting the theater to the number of students attending. So this already gives you a hint as to what your let statement should be. So one is the number of students, and the other one is the cost. So I'll use the letter C for cost. So cost of renting the theater. So therefore our cost is equal to, so our slope is $7. So it'll be 7 times the number of students, plus we have the $130 rental fee, regardless of how many students attend. And this is our equation. Okay, let's take a look at another one. So example 2, Miles A. Head works at Speedy Cars, earning a weekly salary of $800 plus a 5% commission of his sales. Identify the variables writing a let statement. Write a linear equation describing Miles's weekly earnings. So we already know that we want to write something that describes Miles's earnings. So our first part, we're going to let E equal his earnings. And then what does his earnings depend on? Well, his earnings depend on his sales plus the weekly salary. So he has a weekly salary of $800 plus he has a 5% commission of his sales. Okay, so we're going to say S is a sales amount. Okay, so we can say now that his earnings, E, is equal to 5% of his sales. Now, because we have a percent here, we need to change it to a decimal. So it'll be 0.05 times his sales, and then plus the $800. So no matter how much he sells, even if he sells nothing, he still makes the $800. Okay, so this is the linear equation to describe Miles's earnings. All right, let's take a look at another example. Let's take a look at a harder one again, like the one we did at the beginning, but this time we won't draw the graph. So example 3 states, because light travels much faster than sound, you see lightning before you hear a thunderclap. The storm is 650 meters from you. The time interval between the flash and the thunderclap is then 2 seconds. If the storm is 1,300 meters from you, the time interval is 4 seconds. So we're going to identify the variables by writing a let statement, and we're going to write a linear equation to determine the distance from the storm based on the time interval. So this will help us to find our let statement. So we're going to let d be the distance from the storm, and then we're going to let t be the time interval. Okay. Now, because it says to write an equation with a distance based on the time, we know that the distance is the dependent and the time is the independent. Okay, so one little hint, you'll notice that there are 4 numbers and they kind of come in pairs. Okay, 650 matches with 2, 1,300 meters matches with 4 seconds. So what we're going to do is we're going to set up these numbers to find the slope. So usually when you have these 4 numbers, it means that we're going to put them together using our slope kind of formula. So we're going to take 1,300 minus 650, all divided by, now 1,300 matches that with 4. So the first number underneath should be 4, and then minus 2. So when we set up the slope formula, these numbers should match up. So those are pairs, 1,300 and 4, and the 650 and 2 should match up. All right, so we're going to do the calculation. So the slope is 650 divided by 2, and then the slope is 325. All right, next, we need to find the y-intercept. Now, since I didn't draw a graph, we'll need to use our equation. So right now we have y equals mx plus b, and we know that the m is 325, and then x plus b. So we have 2 points again that we can use. So I'm just going to use the 650 and the 2, okay? So we are going to substitute this in. So this is going to be, oh, actually, you know what? Let's replace our x and y, since we're not really using x and y. We're going to use d and t. This helps us actually to also identify where to put the values. So we have 650 equals 325 times 2 plus b. So you have 650 equals 650 plus b. So when I subtract the 650 from both sides, b is actually 0. So now I have my formula, or my linear, sorry, not my formula, my linear equation, which is d is equal to 325 times t. We can put the plus 0, but you don't need a y-intercept of 0. You don't need to write that down, so we're going to erase that. And so our equation is just d equals 325t. All right, so that is how you can write the linear equations based on some data or some information that's given to you.